right, guys, so we are going to finish off section 5.2. I'm recording this lesson in advance just in case I end up being out sick tomorrow. So what I'd like you to do is take a minute and freeze the screen with these 6 warm-up problems. And I want you to see what you can do with these if you can figure out these 6 antiderivatives. Some of them are easier than others. So freeze the screen, work on these 6. Once you've got your 6 answers, then unfreeze, and I'll walk through the answers. So the answer to number 1, remember you have to rewrite this as the integral of x to the negative 4th dx. So the antiderivative would be negative 1/3 x to the negative 3rd plus c, or negative 1 over 3x cubed plus c. The antiderivative of 7 with respect to t is just 7t plus c. This one, you have to remember that this is x to the 1/2, and this is 1/2 x to the negative 1/2. So the antiderivative of x to the 1/2 is 2/3 x to the 3/2. And then this guy becomes x to the 1/2 divided by 1/2, so the halves cancel. You can think of it as times 2. So you end up with 2/3 x to the 3/2 plus x to the 1/2 plus c, or you could write it in radical form. I'd actually accept the rational form or radical form. Either one is fine. Square root of 6x is tricky. You have to break it up and think of it as root 6 times root x. So then root 6 just becomes a coefficient, and then you just anti-differentiate the x to the 1/2. So your answer is 2/3 root 6 x to the 3/2 plus c. The next one, the antiderivative of theta squared is just 1/3 theta cubed. The antiderivative of secant squared, you have to think what function has secant squared as its derivative, and that would, of course, be tangent. The last one requires a little work. I'm going to show you the answer, but just because I need the space. But this requires some identities. So the first thing you have to do is you have to rewrite your 1 minus sine squared as a cosine squared. And then you just kind of break it up and you think, well, this is the same as 1 over cosine times sine over cosine. Well, what is 1 over cosine? It's secant. What is sine over cosine? That's tangent. What function has a derivative of secant tangent? That's secant. So the answer is secant. All right, little review on antiderivatives. Moving on. Today we are finishing off section 5.2 by doing properties of definite integrals. Properties of definite integrals. So we're still not learning how to evaluate them from scratch. We're just going to learn how to work with them a little bit. Okay, so what I want you to do is take a minute and write down these 5. I'm going to talk about them while you're writing. If you need more time, just pause the video. So the integral from a to a, remember that a definite integral represents net area under a curve, or between the curve and the x-axis. So if you're going from a to a, some number to the same number, there is no area. Technically, a line has no area because a line has no width. So I know it seems weird, but it is true. So the integral from a to a is 0. If you need to flip your limits, so if you're going from b to a and you need to reverse them so that you're going from a to b, you could reverse them just by making your integral negative, changing the sign of your integral. This is important, especially when we get into applications. It's really important whenever you're doing an integral that you always write your integrals with your limits going from low to high, with the lower limit being on the bottom and the higher limit being on top. Always want to go low to high. So if your integral is going high to low, you have to flip your limits and make it negative. If you have a constant times your function, the constant can go in front of the integral. That's true for derivatives, integrals, all limits. If there's a constant, you can just put it in front. The next one is same as derivatives. The integral of the sum is the sum of the integrals, so you could do each integral separately. This last one, the integral from a to b is the integral from a to c plus the integral from c to b. What does that mean? Well, if you think about it graphically, now it actually works if c isn't in the middle, but it's the easiest to understand if c is in the middle. So what it's really saying is if I want the area from a to b, I could do the area from a to c plus the area from c to b and get the whole area from a to b. C technically is traditionally in the middle, but it really doesn't have to be, and it can actually be on the outside. You'd just be adding and subtracting, but it would mathematically still work. So our first example today is if the integral from 0 to 1 of x squared dx is 1/3, we've done this a lot now, use properties of integrals to evaluate the integral from 0 to 1 of 4 plus 3x squared dx. So the integral from 0 to 1 of 4 plus 3x squared dx, the first property you're going to use is that sum difference property. You're going to break it up into the integral from 0 to 1 of 4 plus the integral from 0 to 1 of 3x squared dx. And then the last property that you would use, whoops, I just wrote my word twice. So you have the integral from 0 to 1 of 4, and then this 3 could go in front. All right, so the integral of 4, that you have to do with geometry. So remember, for the integral from 0 to 1 of 4, if we have the constant function y equals 4, and we're going from x equals 0 to x equals 1, so and you're finding this area, well, it's just a rectangle, right? It's just 1 times 4. So this integral is actually just 4. And then they gave us at the beginning of the problem that the integral from 0 to 1 of x squared dx was 1/3. So that's just given. So you end up with 4 plus 1, or 5. All right, here comes another one. Suppose the integral from 2 to 6 of x cubed dx is 320. The integral from 2 to 6 of x dx is 16, and the integral from 2 to 6 of just 1 dx is 4. Use this information to evaluate this lovely integral. So pause the recording here. I want you to do this on your own, start to finish, see how you do, and then unpause, and I'll show you the solution. Okay, so first thing I'm going to do is I'm going to break this up into 3 integrals. Okay, now I'm going to put my constants in front. So I have 1/2 integral from 2 to 6. Notice every integral needs a dx. Don't get lazy on writing it. That has to go with every integral. Minus 3 integral 2 to 6 of x plus, and you could keep this just 2. Well, let's put it as 1, so because we're given the integral from 1. Okay, that's 2 to 6 of 1 dx. All right, so now we just use what we're given, right? So the integral from 2 to 6 of x cubed, we were told, is 320. The integral from 2 to 6 of x is 16. And the integral from 2 to 6 of 1 is 4. And then you just add them together. So you get 160 minus 48 plus 8. So you get a total of 120. Okay, little extra practice, very similar, but now we're using some of the other properties. So if the integral from 0 to 2 of x cubed is 4, and the integral from 2 to 6 of x cubed is 320, find the integral from 0 to 6 the integral from 2 to 0, and the integral from 2 to 2. Again, I want you to freeze the screen, take a minute, work on it, and then when you're done with all three, unfreeze, and I'll show you the solutions. Okay, the first one, we don't know the integral from 0 to 6, but we know the integral from 0 to 2 plus the integral from 2 to 6. But we have this pesky -2 in front. I really should have put the -2 in front at the beginning, but that's okay. So I have -2 integral 0 to 2 of x cubed dx minus 2 integral 2 to 6 of x cubed dx. So I get -2 times, let's see, 4 minus 2 times 320. So I end up with -648. Shoot. Okay, I'm going to take this, move this over. Oh my gosh, come on, grab it. There we go. So I can grab all of this. There we go. Whoop. And small. Okay. Okay, so for the next one, the integral from 0 to 2, moving this down a little bit. So the integral from 0 to 2, that's the same as negative the integral, or the integral from 2 to 0 is negative the integral from 0 to 2. So end up with -4. These last two are real easy. And the integral from 2 to 2, it doesn't matter what the function is always going to be 0. All right. The area of each region is given. Find the integral from A to B. All right, take a minute. I bet you can do this in 5 seconds. Pause the screen, figure out your answer, and then start back up again. So the integral from A to B of f of x dx. Remember, integral is the net area. Any area that's above the x-axis is positive. Any area that's below the x-axis is negative. So this integral ends up being 10 minus 2 plus 3, which is 11. So remember, when you're doing an integral, above the x-axis is positive, below the x-axis is negative. All right, one more. It's a short lesson today. So we're going to use area to evaluate this beautiful absolute value function. Eventually we're going to get to a point where we're going to break these into a piecewise, but right now we're just going to use some geometry. So if I graph this absolute value function, remember this is the absolute value of x, but it's been shifted one place to the right. So it has a vertex right here. It's going up that way, it's going up that way. Now, remember, these each have a slope. This line has a slope of -1. This line has a slope of 1. So at -2, we're actually, and you can just plug it in, right? So if you plug in the -2 just to find the y value, at x equals -2, you're up at 3. So I don't know how to draw this well. That's 1, 2, 3. There we go. So let's pretend we're up there. And then at 3, you're actually only at 2. So I'm going to draw these kind of like this. So at -2, we're up this high. At 3, pretend that lines up with the 2. We're up this high. So all we're doing to evaluate is adding the areas of these two triangles together. So the area of the first triangle, so I'm going to rewrite the integral. -2 to 3. Okay, so the area of the first triangle is 1/2 times the base, which is 3, times the height, which is 3. plus the area of the second triangle, which is 1/2, times the base, which is 2, times the height, which is 2. So you end up with 9 halves plus 2, or 9 halves plus 4 halves. So you end up with an integral of 13 halves. That's it. That is the whole lesson. Not much today. So once you've finished everything and you feel comfortable, go ahead and work on your homework in your groups. And then if you finish your homework, you can keep working on quiz 5, the first quiz, 5-1. Have a great day, guys.